We're going to do 5.2.1b. So we're given three different random variables, x, y, and z. They're all normally distributed, and each one gives us our mean and variance. So if you remember, this is going to be our expected value. This is going to be our variance. And in 5.2, we're talking about a normal variables, but then they also want you to remember all of the rules about combining random variables that we learned back in section 2.6 when we talked about what happens when you combine random variables. So this set really is just taking two different chapters and putting them together. The first thing that I would do on this is say, okay, well, what is the expected value of this x plus y minus 2z? Because I need to find the expected value, or mu, before I can do anything else. So remember your expected value rules. So the expected value of x, we'll just pull out expected value of x, plus expected value of y. And then that minus 2 comes out, and it'll be times the expected value of z. So this will be 3.2 for the x, 3.5 for the y, minus 2 times the 12 for z, which gives me negative 17.3. You also need to find the variance of x plus y minus 2z. So using the inner rules, you can do the variance of x plus the variance of y. And that's the easiest part. Okay, plus. Now, when you have a coefficient in front of one of your random variables, to come out of the variance, it has to come out squared. So we'll do negative 2 squared times the variance of z. So our variance of x was 6.5, our variance of y was 3.5, and our variance of z was 7.5. So this gives, forgive me, I forgot the 2 squared. So 4 times our 7.5. Which gives me 40. If I messed up on the algebra here, just ignore it and get to the correct answer on your own. But, so we found our expected value is negative 17.3. We found our variance is 40. And with that, then we can find our standard deviation, which is the square root of 40, which is 6.32. So now basically we have a new random variable with a mean of 17.3, variance of 40, and standard deviation of 6.32. And in fact, let's go ahead and just call this, I don't know, t or w for something. Let's say then that w is distributed normally with all of those properties we just found. That'll make it a little bit easier in my mind to write down. So now it's like any other normal distribution problem. We're not doing anything different. We're just looking for the probability that w is less than or equal to negative 20. So we need to standardize that. So we need to change it to a z. So z is equal to x minus mu over sigma. So in our case, that's x is negative 20, mu is negative 17.3, and our standard deviation is 6.32. So negative 0.427. So we're looking for the probability z is less than or equal to negative 0.427. This is just like any other normal problem at this point. Go to the normal table, look up negative 0.42, and looks like, well, it was 427. So we're somewhere between these two numbers. I just always kind of truncate it and go with this 0.3372. And that is our answer.